Everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 5.3. This is similar to number 16. It says evaluate the following integral using the fundamental theorem of calculus. So in order to do this, I need to know the fundamental theorem of calculus. So I have that right here. So it says, put that right there. States that if f is continuous on the closed interval a to b and f is any antiderivative of little f on a, b, then the definite integral from a to b of our function with respect to x is equal to the antiderivative evaluated at the upper limit minus the antiderivative evaluated at the lower limit. All right, so what we need to go ahead and do is find the antiderivative of this. And then after we make sure that it's continuous, and then evaluate it at the upper limit, 3, and then evaluate the lower limit, 1, and then find the difference there. All right, so if we kind of take a look at this here, this is 1, 3. We can kind of reduce this into two separate fractions here. So the top one, if what is this going to be? So this will be 9s squared over s cubed minus 2 over s cubed ds, and this will become 1 to 3, and this is just going to be 9s to the minus 1 if we bring that exponent to the top and cancel out a couple of those s's there, minus 2s to the minus 3 if we bring that up there, and ds. Alright, so let's go ahead and find the antiderivatives. And let's go ahead and break this apart too, to make this a little bit easier. So 1 to 3, I can pull the 9 out of the first one, and I just have s to the minus 1. And then I'm going to go ahead and do plus. We'll go from 1 to 3, and I'll have negative, and I'll bring the 2 out here, so I'll just have a negative, actually, let me go ahead and leave the 2 in there, because it'll make it a little bit easier, negative 2s to negative 3, and I'll show you why I'm doing that in a second here, ds. Alright, so finding the antiderivative. Now, we don't use the power rule except when we have the exponent to the negative 1, because if we try to add 1 to that, we get 0. Divide by 0, that doesn't work. So whenever we have the exponent to the negative 1, that's when we use the natural log. So it's just a variable with that we're finding the derivative, or the antiderivative with respect to. We just use that, we do the natural log. So this is going to end up being 9, our constant here, times the natural log of the absolute value of that s there, and that'll be evaluated from 1 to 3. And then this is going to be plus, and then this one we're going to add. We're going to add 1 to the negative 3, which is negative 2, and then divide by that negative 2, so those negative 2's will cancel out. So we will just end up having s to the negative 2 there, and that'll be evaluated from 1 to 3. So that's why I left that negative 2 there, so it'll cancel out with the negative 2 that I divided by. Alright, so I'm going to do both of these separately and then add them together at the end there. So this is going to end up being 9 natural log of 3 minus 9 natural log of 1. So 9 natural log of 3 minus 9 natural log of 1. And 9 natural log of 1 is just 0. So this just becomes 9 natural log of 3, and then this one down here is going to be 3 to the negative 2, which is just 1/9, minus 1 to the negative 2, which is just 1, which is going to be equal to 1/9 minus 1, which is negative 8/9. So our final answer is this plus this. So it's going to be 9 natural log of 3 minus 8/9. And we don't have to do any plus c because with definite integrals, that's where we have a lower and an upper limit. There's no constant of integration. All right, that helps. If you have any questions, let me know, and have a great rest of your week. Thanks.